Swayam Prabha. Digital India. Educated India.
Hello everyone. So today's topic is geotextile testing and its analytical approaches. So we have reached the last module of this course. So here we will discuss little bit basic functions of geotextiles, and then uh, um, different analytical approaches of testing of geotextile. So few characteristics we will be taking as some examples. First, let us understand what is geotextile. So geotextile is a member in a group which is called geosynthetics. So basically what geosynthetics, it's something to do with the soil. Okay. So various other members are there in this family. Geonates are there, geomembranes, geogrids, geocomposites are there. So among all these members, geotextile is the highest and volume usage. So unlike other members, geotextile is the true textile structure. It has got true textile structures we deal with here. So geosynthetics is a overall broad classification, broad family. The membranes used to in contact with or without soil are termed as geotextiles. So any membrane which we may be a flexible membrane, maybe rigid membrane. So with or without soil, if we use, it's called geosynthetics. They are used in subgrade stabilization, soil reinforcement, surface erosion control, surface drainage, and many other applications. Okay, basically enhancing the characteristics of soil. And geotextile is, it's a permeable textile structure made from polymeric material, are used mainly for civil engineering applications in conjunction with soil, rock or water. Okay. So they are mainly used in geotechnical engineering application, heavy construction, building, pavement construction, hydrology, environmental engineering. So many applications are there in geotextiles, and other members are geomembranes. It's impermeable sheet of rubber or plastics. Okay, they are used mainly for lining, cover of liquid solid storage. So these are the applications. And geonates are formed by continuous extrusion of polymeric ribs placed at acute angle to each other. The applications are drainage mainly, and geogrids are there. These are the plastic materials formed into a very open grid-like structure. That's why it's called geogrid, with very high apertures. So separation and reinforcements are the main applications, and geocomposites are usually more than one geosynthetics are used together. Now, if we try to see the classifications, different types of geotextiles, so based on material type, geotextiles are classified based on manufacturing method. So based on manufacturing method, they are classified as oven, heat bonded non-woven, needle punch non-woven, chemically bonded non-woven, spun bonding, knitted. So these are the different types of geotextiles. Now if we see the functions, the different functions of geotextiles are: one is the filtration. So to prevent the erosion, to prevent the soil particles or sand particles flowing along with the water, geotextiles are used. So which will allow the water to pass through, but it will retain the soil from erosion. Okay, drainage. So there are many applications where the water logging is there, and due to water logging, soil strength reduces. So with the increase in moisture content, strength of soil reduces. Soil has got very poor strength when it's moist. So basic idea of geotextile here is to drain out the excess water present there. So this is mainly for pavement or railway track construction, where water has to be drained out. Protection. Protection means different types of cushioning effect is required, so that the structure doesn't get damaged. Reinforcement, so soil structural strength improves using the geotextile. Separation is very important function of geotextile, which will segregate the gravel from the soft soil. Okay, so that in between these two material, so some thick stones and large stones and the soft soil. So when geotextile is placed, so they are separated. Otherwise, without geotextiles, these stones, gravels will penetrate inside the soft soil, and the structure will get destroyed. Now we will discuss different evaluation techniques of geotextiles and their analysis. So geotextile testing, they are actually conducted in two different ways. Like in normal textile, we test the material in the lab. So this, when we use the material, we test the material in the lab, it's called index testing. Okay, so index test or in isolation test, tests are performed in the lab only on geotextile itself. So we know certain characteristics for comparison purpose. Another is that performance test. Performance test is that when we test the material, okay, along with the soil, site specific soil, and keeping the same condition, then it's called performance test. Like tensile strength, when we test in the lab, it will have some that index value, but when we test the material, when with using that index value, when we test the material with the soil, the characteristics will be different. So there will be physical testing, mechanical testing, hydraulic test. So physical characteristics we will test. So we test the mechanical characteristics, then we test hydraulic characteristics. These three types of tests are important, characteristics are important, and along with that endurance testing, means actual use, actual performance, how it will perform, geotextile will perform, that for that endurance test is also there. And degradation testing. Degradation testing means after long time how the performance is deteriorating. That also we can test by degradation testing. Now physical properties are specific gravity, mass per unit area. It's normal for any textile material, thickness, stiffness, and mechanical characteristics are tensile characteristics, fatigue strength also we test, seam strength. Basically, generally in case of geotextile, say road construction, the size of the road, so it's continuous, maybe thousands of kilometers, but we cannot manufacture the geotextile in that dimension. So geotextile, there is a limitation in width and length also, roll length also. But when we want to use this in the road construction, then we have to impart some seam. So seam strength is a very important characteristics of geotextile. Bust strength is important. We'll discuss how we can predict the performance by knowing the bust strength. Where will it use in actual application? Impact strength is also important, because sometime during the site application some stone may drop on the geotextile, and if it damage that part, that will actually deteriorate the performance. So we need to know the impact strength. Tear strength is very important. Compressibility, because with the increase in compressibility, so as the geotextile get compressed, the performance, particularly hydraulic performance, changes. So that is also important, we must know. Frictional behavior is also very important, because the load transmission from soil to fabric and fabric to soil is basically takes place through the frictional contact. Puncture strength is important. So and pull out test, which is actually connected with the shear strength, soil and geotextile shear strength, and direct shear pull out test and direct shear test also, they are important mechanical properties. Now let us try to see what is the dynamic puncture strength. Here this is a clamping ring, okay, and protection cover is there. 1 kg pointed cone. So this is standard weight 1 kg pointed cone is dropped from a height, say 1 meter. 1 meter height, it is dropped onto a stressed geotextile specimen. Specimen in stressed condition. On that, if it is normally, it's not in loose condition. Loose condition, then impact puncture will not be there. So it will be a stressed condition, with a standard stressed condition. There the specimen that the cone is dropped on the specimen, and depending on the puncture strength, the cone will penetrate inside the fabric. So if the puncture strength is very high, then penetration maybe will be 0 or maybe little bit lower, and with a lower puncture strength the penetration will be more. So from there, the diameter, what is the diameter of the hole made by the cone is measured by graduated cone. So the graduated cone is there. From there one can measure the diameter of the hole. So larger the hole diameter, lower is the puncture strength. So this is the standard method of dynamic puncture testing. Then bust strength. Bursting strength, there are three types of burst strength. One is Mullen burst strength, then ball burst strength, and severe burst strength testing. So the Mullen burst strength is normal in our normal textile material. We use a diaphragm type in. So there will be a geotextile, okay, and a ring clamp is there, and hydraulic pressure is applied, and we can get the burst strength. And ball burst strength also, in case of textile material, we use particularly for high stretchable fabric like knitted fabric. We use ball bursting strength, where the ball penetrates from here, from the bottom portion, and we get the strength, and in terms of load value. Okay, here we get the strength in terms of load, here in terms of pressure. This we have already discussed in previously also. And severe burst strength, this is the severe instrument, which this severe California bearing ratio test is basically done for the compressibility of soil. Okay, this instrument is used to measure the strength of the soil, and this same principle we can use for the bursting strength measurement. So analytical approach is that bursting strength is required to design the geotextile for separation purpose. So when we are having a soft soil, and as I have mentioned, this is a soft soil, and here it's a gravels are there, stones are there, and in between we are using these are the soft soil, and in between we use the geotextile. This is the geotextile. So here basically bursting strength is important. We can see here, so subgrade soil is there and stone aggregate, okay, and in between the geotextile is there, which is shown by red lines. And when the load, the truck is moving, load is applied downward, heavy load is applied, the subgrade soil will try to pump inside the stone, and the geotextile is acting as a separation function is there. Okay, now try to see, we just enlarge a particular portion, we are enlarging it, this is enlarging. Now we can see the stones are there. Let us take three stones, 1, 2 and 3, and when this load is applied, thus this stone, this one, these two stones will try to move downward, and the soil will try to pump inside. Okay, and here if the geotextile is placed here, so this will be acting as a, like as if the pumping is taking place, that is a bursting is taking place. It is similar to Mullen burst strength tester, where in here it's a subgrade soil, but in the testing we have used some fluids. Okay, this is the field model for bursting strength resistance testing. Geotextile is being forced up by pressure Pg. This is a Pg is a pressure here into the void of stones. Okay, this is the void of stone. Okay, so due to the traffic load, and this load is there, Basically it's nothing but the whatever pressure is applied is nothing but the trier inflation pressure is equal to trier inflation pressure. Now it can be analogous to the in the field condition like stone puncturing into the separation layer. So that's we have already discussed. Okay, so the inflatable rubber membrane is used with 30 millimeter diameter, and here this is the empirical equation is given here. Okay, so ultimate strength of the tensile strength of the geotextile T alt, okay, is given by half PB is the bursting strength. When we test the bursting strength is a PB. DB is the diameter of the burst equipment where it's a 30 millimeter here, and strain in the geotextile epsilon G. So if we get, so it's an empirical equation. From there we can actually predict the ultimate strength of the. So if we know the ultimate strength of the geotextile, from there we can calculate the maximum pressure which can be actually resisted. Now next is that stabilization and reinforcement and stabilization. So when we apply geotextile, it gets high compression. Okay, so so due to the load, the soils is a structure with high compressive strength but low tensile strength. Soil has got very low tensile strength, and geotextile we apply with a high tensile strength which will enhance the strength of the structure, okay, increase the soil quality, and which increases the structural stability of soil. So geotextile effectively increases the load bearing capacity of the soil through the tensile mechanism. Okay, so you can see, and three different types of mechanisms play for reinforcement structure. So here geotextile strength, tensile strength is transferred to the to enhance the strength of the soil. So the transfer mechanism, one is that membrane type reinforcement, that is when vertical load is applied to a geotextile on a deformable soil. Okay, that means this is a soil structure, and this is geotextile, and okay, when soil vertical load is applied, that means this soil structure is deformable. The load, that soil will try to move laterally as it is deformable with a low tensile strength, and due to the surface contact with the geotextile will try to restrict this movement. So the tensile load will be experienced by the geotextiles. So that will enhance the strength of the structure. The structural strength will be enhanced. Membrane shear type deformation, a geotextile that is placed on soil is loaded in the normal direction, and two materials are sheared at their interface. So there will be shear between the soil and the geotextile. And another is anchorage type reinforcement, that is tensile forces applied on the geotextile that is surrounded by both sides, so by the soil. Okay. Now membrane type, let us see the relationship is that this is the relationship of membrane type reinforcement, where vertical load is applied on the geotextile on deformable soil. Okay. And depending on the depth of position of the geotextile, the load is actually transferred to the geotextile. Okay, this is the load transfer. Okay, load transfer is the sigma h is the horizontal stress at the depth z and angle theta. That means you can see here, this is the geotextile. Okay, here is a soil. Now here you have a load applied. Now this is the depth z, and suppose here is the load applied. Now at angle theta, this is the theta. At this point, if you want to get load on the geotextile, so this is the formula. Here theta is the angle, P is the applied vertical load. Here P, when vertical load is applied, Z is the depth of the surface, that is Z is the depth of the surface, where this sigma h is being calculated. So at this point sigma h is calculated. Mu is the Poisson's ratio of subgrade soil. So subgrade soil Poisson's ratio is given, mu, that is, say, can be calculated, that is known, and theta is the angle from the vertical beneath the surface of the, so this is the theta. So at this point, if we want to calculate the load on the geotextile, that we can calculate by using this relationship. Now what will be the load exactly at the bottom? So in that case theta will be 0 degree. Okay, 0 degree. So if we use theta 0 degree, and this relationship will be reduced to, so you can use 0 degree, so this will be 0, here it will be 1, so then it will be reduced to some form, okay, which indicates that directly beneath the load, the larger the magnitude of P, so P, if we increase the P, that means load on the fabric will increase. Higher is the tensile stress on the fabric, the higher the requirement of the tensile strength of the geotextile. So that means for higher load, applied load, so we need higher tensile strength of the geotextile, and also closer the geotextile to the load, that means at the towards the surface Z. If Z is lower, then low value of Z, the higher will be the geotextile. So that means if we apply geotextile at in the close to the surface, that means higher strength is required, and if we apply the geotextile at the depth, certain depth, that means stress requirement will be low. Many situations in which geotextile are placed on soft soil or in yielding situation, this particular reinforcement. So for this, actually this type of situation, membrane type of anchoring, membrane type of reinforcement is basically, it's used only in the soft soil or yielding type situation. For hard soil, we don't counteract this type of mechanism. Next is the shear type mechanism. A geotextile is placed on soil, is loaded on a normal direction, and then two materials are sheared. So they will be actually that movement will be there. This results shear strength parameters, addition and geotextile to soil frictional angle. So these two characteristics are there. So here from this tau is the shear strength, the sigma n is the effective normal stress, C is the adhesion, and theta is the frictional angle. From there we can calculate the shear strength. Okay, mechanical characteristics, it is characterized by shear strength developed between the soil and geotextile. So to reinforce with the soil, high contact shear strength is required. So if the shear strength in normal case, so we need high shear contact shear strength is required, but sometimes we may require a low contact shear strength where the sliding is preferable. So but in most of the cases geotextile application we need high contact shear strength, and that is measured by two methods. One is pull out method and direct shear method, okay, which measures the interactions between the soil and the geotextile. Now this is the pull out test, where the geotextile is being placed in between the soil are placed in both the sides, and we pull the geotextile, and depending on the frictional contact, and there is a normal load is there, so the pulling force is noted. Another one is that the geotextile is placed between the soil, two boxes are there, so normal pressure is applied, and then one box, the top box is being pulled, and depending on the frictional contact we can get the frictional angle between the that frictional angle, and we can get the frictional coefficient between the soil and geotextiles. Next is the shear type. The shear strength parameter that we have already discussed, C and sigma, can be compared to the shear strength parameter of the soil by itself. So with fabric and without fabric, that we can compare to get the shear strength parameter. And anchorage type, so anchorage reinforcement is similar to the shear type, but here the soil acts on the both side of the geotextile. And for calculation, they are shear strength mobilized by the geotextile with the soil above and with the soil below, and arithmetic mean, arithmetic sum. So arithmetically the sum of two values are actually the value of the anchorage value, the limiting anchorage value. So top side and the bottom side, that value has to be added.